And so there's one thing we haven't told you about yet with the asymptotes, and that's called a slant asymptote. We only get a slant asymptote if n is one more than m. So we're talking about the degrees of the polynomials. So remember we had f of x equals a sub n x to the nth, and then blah, 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 over b sub m x to the nth plus blah, blah, blah. Those were our polynomials. And we said, well, if n is greater than m, there's no horizontal asymptote, which is true. But if n is just one more than m, so if n equals m plus 1, then you can have a slant asymptote. Then there's a slant asymptote. Okay, and so they don't really do a lot with this. It comes up, but we're not going to do a lot of examples or anything. It says find the slant asymptote. To find it, you divide. You divide this division here for your rational function. So see how this has an n of 2? But this has a degree m equals 1. So because 2 is 1 more than 1, so if it were like 4 and 3 or 5 and 4, those would each be a case where you would have a slant asymptote. Okay. To find that, then we're going to divide. And because this is linear, we can use synthetic division. So I'm going to go 3 into, and I'm going to pull off those coefficients. And I'm going to go with my synthetic division. Okay, and it turns out the remainder doesn't really matter. We don't really do anything with that. But this right here, those coefficients, because this was x squared, now this is linear. And that's always going to happen. If it hadn't been a linear factor, you could still divide, but you'd have to use long division. But we did the division synthetically this time, which is fine. But that means we have now x minus 1. Well, what that is going to be the equation for your slant asymptote. So there it is. I just found the slant asymptote. I divided the numerator by the denominator. If you can use synthetic division, great. If not, then you use long division. But no matter what, this is always going to be linear. That's why it only works if the degree is one more than the other one. Okay, so what does that mean? Well, I can graph this. This is a line. Okay, has a slope of 1 and a y-intercept of -1. Okay, so I can go to 0, -1, and my slope is up 1 over 1, up 1 over 1, and I could draw this dotted line. That is the slant asymptote. I didn't draw it very well, but that's the slant asymptote. You also have a vertical asymptote at 3. X equals 3 is a vertical asymptote. There's no horizontal asymptote. There's just a slant asymptote and one vertical asymptote. And so you see how it divides kind of the graph into 4 different sections. So to graph it, you'd have to find points. I'm not going to graph it, but that's what you would have to do. You could find the x and y intercepts and things like that and go through the regular strategy, but those are how the asymptotes would work, okay? And in this example, they just ask us to find the slant asymptote, and then they were kind of done with it. But you could find more points. You could find the x-intercepts and the y-intercepts. Okay, so that is that.